19.4. Multiply decimals by one-digit whole number. I can multiply a decimal by a one-digit whole number using the distributive property partial products in an area model. Stepping out, oceanographers recently discovered a new species of sea sponge in the Pacific Ocean. Sponges are animals, not plants, and can be found in both seawater and freshwater. Some sponges are able to move about 2 5/10 millimeters each day. How far might a sponge move in 1 week? Write a numerical expression to model the situation. So what do we need to use? So 2 5/10 millimeters each day. How far might it move in 1 week? So we need to know how many days there are in 1 week. How many days are there in 1 week? 7. So you would take 7 times 2 5/10. What do the factors in your expression represent? Okay, so the 7 represents what? 7 equals the number of days in a week. And then the 2.5 millimeters equals how far the sponges move each day, right? Okay, so you can use the distributive property to multiply. So first of all, they want us to break apart our numbers into smaller things so it's easier to work. So basically, they said you're going to take 7 times, and then we would break the 2.5 into a 2 and a 5/10. So then you would plug it through, the 7 through. So you would take the 7 times the 2, and then you'd also take the 7 times the 5/10. That's how you do distributive property, right? So then, what is 7 times 2? 14. And then they said you'd still take 7 times 5/10. So you'd have 14 plus, what is 7 times 5? 35. But then you have a decimal point, so you have to represent that. So it'd be 3.5. So 14 plus 3.5 is 17.5. So how far might a sponge move in 1 week? Millimeters. So 17 and 5/10 millimeters. Stepping out, number 2, the current rise in sea level is generally thought to be caused by the melting of ice sheets and glaciers. Scientists estimate that the rise in sea level is about 3 2/10 millimeters each year. What is the expected rise in the sea level after 8 years? So we have the 3 2/10 millimeters, 8 years, and then they want to know what the expected rise is after that 8 years. So write an expression that models the situation. So what is our expression? Okay, or 8 times 3.2. What is an estimate for the rise in the sea level? So estimate. So we want to estimate them to what? Both be whole numbers. So 8. So 8 times 3, which equals about what? 24 millimeters. Multiply by showing partial products. First, multiply the 2/10 by 8. So this is where we kind of do the distributive property, except for put them in different chunks, right? Okay, so what is 8 times 2/10? Well, 8 times 2 is 16, but then you have one decimal place, so it'd be 1.6, right? Okay, so then that gets us 16/10, or the 1 6/10, right? Then multiply the 3 ones by 8. So 8 times 3 is 24. So 24 1 or 2 10s and 4 1s. So what is 24 plus 1 6/10? 25 and 6/10. So what is the expected rise in the sea level after 8 years? So 25 and 6/10 millimeters. So how do we know our answer is reasonable? So we know our answer is reasonable because 25 and 6/10 is close to 24. Number 3, coral reefs grow about 1 in 2,500 centimeters each year. About how many centimeters does the coral reef grow in 9 years? So we have 1 in 2,500 centimeters, 9 years, and they want to know how much it grows then. So to solve, find 9 times 1 in 2,500. Use an area model to find the product. Okay, so we're taking 9. And then we are going to break apart the 1 in 2,500. So what would we break it into? 1 and then the 2,500. Okay, and then this is where we come across and have it meet up. So what is 9 times 1? 9. And then here we come across and go up here. And then what is 9 times 25? What's 9 quarters? 225, and then we have how many decimals? 2. So 2 and 2,500. So add the areas of the two sections. So we would add 9 plus 2 and 2,500, which equals 11 and 2,500. So about how much does a coral reef grow in 9 years? 11 and 25. So about, because they use the word about as well, right? About 11 and 2,500 centimeters. Okay. So we're seeing a fisherman has 6 limited mackerel. Each mackerel weighs about 1 and 7,800 pounds. What is the height of the fish, or of the 6 fish? So we have the 6. 1 and 7,800 pounds. What is the weight? Now, we can use any of those models, right? Okay, that we just did. Can we also just work it out normally? Yes. Yes. Let's use the distributed property on this one. Okay, or do you just want to work it out normal? Okay, so 1 and 7,800 times 6. So, do I act like there is a decimal there yet? Oh, no, I do not act like there is a decimal there yet. We just work it out normal, and then we go back and put in the decimal, right? So 8 times 6 is, carry the 4. 6 times 7 is, plus 4 is 46. Carry the 4. 6 times 1 is, plus 4 is, and then bring my decimal over 2 spots. So 10 and 6,800 pounds. Okay, next one, 3 times 6 is, or do you guys want to do one of the other ways? Okay, regular. Okay, all right, 3 times 6 is, carry the 1. 3 times 8 is, plus 1 is, and then how many decimal places? 1. Okay, next one, 5 times 7 is, put the 5, carry the 3. 5 times 3 is, plus 3 is, carry the 1. 5 times 1 is, plus 1 is, 3, or 5 times 2 is, okay, and how many decimal places? 2. Bless you. Now, you guys want to do it normal, you want to do distributed property, the partial products, or the area model? Normal. Okay, 8 times 3 is, with the 4, carry the 2, 8 times 9 is, plus 2 is, and then carry the 7. 8 times 7 is, plus 7 is, what do you guys say? And then how many decimal places? 2. So 63 and 44 hundredths.